Okay, here we go. So we're looking at the small intestine, and we are looking particularly in this video at the ileum. So not quite as cool as the duodenum, but you know, it's getting there. Structurally, I think if you see it looking, down a microscope, which is the view that we've got here, then pretty much you'd be thinking, yeah, that looks pretty much like the duodenum, and it pretty much does. It's got the villi, and we'll go into more detail into the structure of the villus soon. We've got these lovely crypts of Leberkuhn. Why they haven't finished that label off, I don't know. So, no, there we go. I'll put it in, Leberkuhn. If I ever discover any crypts, I'm going to call them that. People can visit them on holiday. Then we've got so all of that together, that's the submucosa, the mucosa. And then we've got the submucosa, stop making me laugh. Submucosa, layer of circular muscle, layer of longitudinal muscle, and the serosa around the outside. That's its adaptation. So, what does the ileum do? I think we're talking mainly absorption here. So I'm just going to do a quick sort of sketch of a villus. And definitely you should be able to label a villus, and you should know what sort of cells there are in a villus, and you should be able to draw those cells. And it's pretty straightforward stuff, and it is always really, really badly answered on exam questions. So here we're looking at the lumen of the gut. Remember, that's the hole down the middle. So pretty much if you saw it from sort of a transverse section, the villi are sort of sticking out into the middle, and this bit there, that's the lumen. So this is where all your digested, your products of digestion are. So what are we talking about? By the time we get down to the ileum, we're pretty much looking at, from carbohydrates, we've got glucose, we've got some dimers, so we've got sucrose, maltose, and if you're a milk drinker, we've got lactose. As far as proteins are concerned, we've got amino acids, they're obviously the monomer, and we also have some dipeptides, which are the dimers, and of course from fats we've got glycerol and fatty acids. So that's what's sort of hanging around in the lumen, and you need to get it absorbed and into your body. So all of these cells here, this is your epithelial layer. So running just underneath the epithelial layer, and you've got to imagine this in 3D. I don't know why you have to imagine it in 3D. Imagine it in 3D if you like. How's that? You've got a capillary network. So the blood is coming in through an arteriole, dividing up into capillaries, and this is bringing, there we go, and that brings oxygen. Sorry, I lost the plot a bit there, didn't quite realise that. And it's going to drain away into a venule, and this is important because this doesn't just drain back into circulation, this drains back into the hepatic portal vein. So, why so? And hepatic, you may realise, means liver. So what's this got to do with the liver? So your circulation pretty much goes like this. You've got your liver there. I'm going to do my gut in red down here. And it's got all these blood vessels. It's folded up into microvilli, and everything, all of those blood vessels kind of collect together and they drain and they take stuff into the liver. Now if you think about it, what's happening here is we're going to absorb things, these products of digestion, and put them into the bloodstream. So if you've just had a big meal, this is, you know, an hour or so later, this is going to be absolutely chock-a-block with glucose, amino acids, all the products of digestion all heading off to the liver, and then you don't eat for a while and it's going to be empty. So that sort of levels of glucose particularly, I think, are really sort of up and down in this blood vessel. So what the liver does is it sorts all that out. So it does things like protein synthesis with the amino acids. It makes glycogen and it makes fats with the excess glucose. And so what goes back out into your general circulation, so this is the one this is the hepatic vein. This is going to be going out with a fairly constant glucose, and of course, you know, between meals it may well be putting some glucose into that circulation. The other structure that we see in the villus is a lacteal. So these are called lacteals because they look milky in colour, and the reason that they look milky in colour is that they're absorbing fats. So this is a lacteal. And it absorbs fats. And the sort of story of fat digestion is not only completely fascinating and a little bit unusual, but also something you can look up yourselves. So, capillaries. Absorb glucose and amino acids. So now we've got the sort of overall picture, and I'm thinking this is 7 minutes long already. In the next video you can join me and I'll talk you through the sort of real nitty-gritty of absorption of glucose, which is again a fascinating story, and perhaps we'll look at some of the features of epithelial cells. Just before we move on, just remind you that some of these will be goblet cells. And just remind you of the structure of a goblet cell. So, looking like a goblet. Oh, I'm so good at drawing. And if you remember, this goblet, they're making mucus to protect the cells from enzymes. It pretty much fills up with mucus, and then it kind of spills over the top to protect all the adjacent cells. And those cells, of course, being replaced from the crypts of Liebe. Okay, lovely jubbly. See you in the next video.